Hi Year 12. So today's video is looking at integration again, and we're going to be looking at integration by substitution. So we're going to spend a couple of lessons doing that. Today we're going to be just looking at the basic substitutions and looking at very simple questions, and that will relate to 12D. Once we've mastered that, we'll move on next lesson to 12E and look at some harder, a little bit different scenarios. Okie dokie. So a lot of the questions that we've been doing by the reverse chain rule in integration, we can now do by substitution. You will not specifically be asked in the HSC to use substitution. You'll just be given an integration question, in which case you will have to decide what you want to use. But I'm pretty sure you'll end up using this a lot. So I'm not going to go through all of these bits. Okay, I'm going to talk it through here, look at the steps, and then have a look at some questions. So the gist of what we're wanting to do with integration is we're wanting to have a look at an integral between a and b, sometimes we won't be given the limits, of some function with respect to x, and we're going to come up with something that we want to substitute in for part of our function, and we generally use u as a substitution, and we're going to change our function in terms of x to a function in terms of u. So instead of integrating with respect to x, we're going to be integrating with respect to u. So we're going to have to come up with also a substitution for the du part. And we're going to have to change our limits. With function x, we have limits that are x values, and we need to change those to respective u values. So let's have a look at the steps. So we're going to let u equal a function in f of x. We're going to find du dx and shuffle that around to get a value for du. We're going to find corresponding u values for the upper and lower limits b of a. We're going to substitute into the integral so that we eliminate all of the original x values and f of x's and dx's, integrate as normal, and then sub back in our original u value. So we're going to work through a question doing all those things now. The first question will not have the integrals, b or a, but we'll have a look at some of those in a moment. So we're going to start fairly simple. So here's our first example. We're going to integrate x squared plus 1 or to the power of 3 times 2x dx. Now, you probably could use the chain rule to do this one. I mean, the reverse chain rule, but we're going to use a substitution. I'm going to say let u be equal to x squared plus 1. Therefore, if we integrate our u with respect to x, so we get du dx, we're going to get 2x. And then what I'm going to do is I'm going to multiply both sides by dx, because these two parts we haven't used as separate parts before. We've just thought of it as the change in one with respect to the other, but it's du over dx. Multiply both sides by dx, and I'm going to get du is equal to 2x dx. So what I then have a substitution for is the u, which is to the power of 3, and 2x dx is du. So if we have a look over to the right here, I'm going to have u to the power of 3, there it is there, and two ways you can think of it. I might just change what I've done here a little bit because I have an option there, but I'm going to go, instead of 2x dx, which is here, I'm going to have du. So I'm integrating u cubed with respect to u. So let's do that. Let's add 1 to the power, divide by that new power, plus c. But our original question was given to us in terms of x, so we need to give our answer in terms of x. So where there is a u, we're going to pop that x squared plus 1 in. So I have the 4 on the bottom, I can write as a quarter out the front. X squared plus 1 to the power of 4. Okay, that's my u there, to the power of 4 plus c. And that is my answer. And that's what we want to have a look at today. Although I've got more information down the bottom there, I'm not going to do those today. We're going to look at those in the next video for next lesson. And we're going to go and have a look at the textbook now and have a look at some nice, simple answers and questions.